everyone. Today we are going to tackle about finding absolute extrema. So here is the procedure for finding absolute extrema or finding absolute extrema of f of x on AB. So first, we have the step 0. Verify that the function is continuous on the interval a and b. Step 1. Find all critical points of f of x that are in the interval AB. This makes sense if you think about it. Since we are only interested in what the function is doing in this interval, we don't care about critical points that fall outside the interval. Step 2. Evaluate the function at the critical points found in step 1 and the endpoints. Step 3. Identify the absolute extrema. So there really isn't a whole lot to this procedure. We call the first step in the process step 0, mostly because all of the functions that we're going to look at here are going to be continuous. But it is something that we do need to be careful with. This process will only work if we have a function that is continuous on the given interval. The most labor-intensive step of this process is the second step, which is the step 1, where we find the critical points. It is also important to note that all we want are the critical points that are in the interval. So, now let's do some examples. So, since we are assigned to example number 4, which is in page 315, so here is the example. Suppose that the amount of money in a bank account after t years is given by a of t is equal to 2,000 minus 10 times t times e raised to 5 minus t squared over 8. Determine the minimum and maximum amount of money in the account during the first 10 years that it is open. So here is the solution. Here we are really asking for the absolute extrema of a of t on the interval 0 and 10. As with the previous examples, this function is continuous everywhere, and so we know that this can be done. We'll first need the derivative so we can find the critical points. The first derivative of t is equals to negative 10 e raised to 5 minus t squared over 8 minus 10 times t times e raised to 5 minus t squared over 8 times negative t over 4 is equals to 10 times e raised to 5 minus t squared over 8 times negative 1 plus t squared over 4. The derivative exists everywhere and the exponential is never 0. Therefore, the derivative will only be 0 where negative 1 plus t squared over 4 is equals to 0 and t squared is equals to 4. T is equals to positive and negative 2. We've got two critical points. However, only t is equals to positive 2 is actually in the interval, so that is only critical point that we'll use. Let's now evaluate the function at the lone critical point and the end points of the interval. Here are those function evaluations. A of 0 is equals to 2,000, A of 2 is equals to 199.66, and A of 10 is 1,999.94. So the maximum amount in the account will be $2,000, which occurs at t is equals to 0, and the minimum amount in the account will be $199.66, which occurs at the 2-year mark. In this example, there are two important things to note. First, if we had included a second critical point, we would have gotten an incorrect answer for the maximum amount, so it's important to be careful with which critical points to include and which to exclude. All of the problems that we've worked to this point had derivatives that existed everywhere, and so the only critical points that we looked at were those for which the derivative is 0. Do not get too locked into this always happening. Most of the problems that we run into will be like this, but they won't all be like this.